Hello.
Hello, hi.
Hi, how are you?
Fine, you.
Yeah, so I am also fine for thanks for joining. So actually I am busy with my some other tasks, so that's why I'm not joining at the perfect time. Yeah. Okay.
No problem. No problem.
Okay, thank you. Thank you. Okay.
You're welcome.
So hope everything is good and you also practice all of those recorded classes and also get all of
Yeah.
this practice code. Okay,
Yes.
so yeah. So today I think
Our,
this is our fifth number of class. Okay, four number class is already done. So today is our fifth number of class. So mainly today I will try to discuss about that air quality monitoring, how we can easily monitor the air quality using the remote sensing technique. This process I also try to discuss mainly carbon monoxide, then sulfur dioxide, then methane, then also nitrogen dioxide. So these type of gases, how we can easily monitor using the Google Earth Engine platform as well also using the remote sensing technique. So different types of sensors such as Sentinel-5. Mainly Sentinel-5 is access the data about that air quality parameters as well as also have some other data sets such as Landsat, also Modis. From the Modis, we can also access the some air quality parameters data. Okay, so we also try to discuss a lot of things such as how we can easily make the air quality density map. Suppose you want to make the air quality density map, where the place is the high density, where the place the low density about the carbon monoxide emission or nitrogen dioxide emission, as well as we also check about the temporal changes when the it will be high, when it will be low. Okay, so this type of analysis, as well as we also try to calculate the total emission. Suppose any specific time, how much carbon monoxide gas is emitted in a particular time period. Okay, we also try to calculate this type of calculation using the remote sensing technique. So I hope you can easily learn all of the things. So now let's jump our class. So I just simply share my screen. Okay, so let's go. So now can you see my screen?
yes.
Okay, so let's go. So let's go. I simply open my slide. So basically today is our fifth number of days, and today I will try to discuss about that how we can easily calculate the different types of air quality parameters density map. It can be nitrogen dioxide, it can be sulfur dioxide, it can be carbon monoxide, it can be methane, it can be nitrogen dioxide. So all of those gases, how we can easily make the density map and also check where the density is high, where the density is the low, all of these things. As well as we also try to discuss about that how we can easily download the air quality parameters time series data in CSV file format using the Google Earth Engine platform. Then how to convert this unit mole per meter square to molecules per centimeter cube, how we can easily make the conversion, how to make the time series chart of these air quality parameters, and finally how we can easily export this map and use the ArcMap software, as well as how we can easily calculate the total emission for any specific gases for a specific time period, how much gas is emitted in a particular time period. Okay, this type of calculation we also try to discuss. Okay, so let's go. So first of all, here you can see we can get the two types of map in here. So one map is represented the methane concentration of Kuwait. So basically you can see the this type of region, red color, it's identify the high concentration of the methane. Okay, so this type of region, high concentration, also in here. Okay, and it will be almost 1914.57 parts per billion ppv unit. It's the ppv unit. And also we can see the this type of color, it's showing the low density about the methane concentration. Okay, so as well as also you can see this is the another task about that nitrogen dioxide concentration map for Bangladesh year of 2020 January, month of January. So mainly we can easily identify, you can see high concentration. Mainly the unit is the mole per meter square. Okay, per meter square, how much mole gas is available. So this is the calculation for the mole per meter square. So here you can see high, it will be showing this type of color. So we can easily identify this is the center of the capital of Dhaka city. Okay, so that's why the lot of emission of nitrogen dioxide taken in here. Okay, and we can also observe it from this Sentinel-5 satellite imagery also. We can get the same result. Okay, and it's showing the high density region of the nitrogen dioxide, as well as we can also get the low density, such as you can see for the forest, it is the mangrove forest in Bangladesh. So for that you can see there is a very low density about that nitrogen dioxide, as well as also you can see this is the hill track region. Hill track region, there is the no activities, so that's why we can also get the very low emission. You can see E inverse 5, okay, mole per meter square, very less. And beside that you can see this is the also we can also get the some also density about, because it is that we can also do the port or trade place. Okay, so different types of maritime boundary in here, so different types of ship or different types of vehicles are going here. So that's why it also increasing the density of the nitrogen dioxide. Okay, so this type of data we can easily access from the Sentinel-5 satellite imagery and also create this type of map. Okay, so let's go. Also you can see this is the another maps about that nitrogen dioxide level rebound in Bangladesh for the different time period. Okay, so here you can see first map represented the before lockdown. In the COVID situation before lockdown, we can get this type of special distribution about that nitrogen dioxide. Okay, so this is the before lockdown, and it also showing the post lockdown, and sorry, during lockdown it's showing the during lockdown and post lockdown. Okay, so after the when during lockdown period is in, then also people go out the home and also go to the road, and also all of those industries, all of those factories, all of those other types of industries will be opened after lockdown. Okay, then we also can see that you can see it will be also more distributed about that nitrogen dioxide level. Okay, more place will be distributed. Okay, but past time you can see during lockdown we can get only for the Dhaka city. Another reason you can see there is a no very low distribution about that during lockdown. Okay, also you can see very low about this place. But when it will be finished the during lockdown period, we can find out the more levels of nitrogen dioxide will be rebound and also spread for the whole country. You can see it will be showing the more nitrogen dioxide level rebound in Bangladesh after the during lockdown. We can get the post lockdown this type of image. So basically all of those analysis we can use the Google Earth Engine platform and also use the Sentinel-5 satellite imagery. Okay, and Sentinel-5 satellite imagery, just we can make all of those things as a TIFF format, and then we can finally download this map as a TIFF format and work with the ArcMap software. For creation this type of map we are using here the ArcMap software. Okay, so let's go. As well as, okay, so now we talk about the air quality monitoring using the Sentinel-5 satellite imagery, how we can easily monitor the air quality monitoring. So basically Sentinel-5, it mainly focused on air quality and composition of climate interaction with the main data products being ozone, nitrogen dioxide, sulfur dioxide, as well as also formaldehyde. So this type of gases, it will be easily accessed from the sensor. And this is the data set about that. You can easily go to this link and you can easily access all of those Sentinel-5 data set. Okay, so now I simply go to this link and open this link and try to show you that how we can easily import the data set, then how to filter this data set, and how to reduce this image collection, and how to click on your own shapefile, and how to display the result on the map. Okay, so let's go. Just I simply open a new code editor. Just a minute. So yeah, so just open a new code editor and try to show you that all of this process. So first of all, I simply click on here and go to this, you can see browse data catalog. Okay, so click on here. So now it browsing my all of those data set. You can see Sentinel. So just I simply click on the Sentinel. So because I have to use the Sentinel-5, so just I simply open the Sentinel-5. You can see Sentinel-5 Tropomy or tropospheric monitoring instrument. So mainly in this data set here you can see the aerosol index, cloud. Also you can see the carbon monoxide, formaldehyde, as well as also you can see the nitrogen dioxide, ozone, as well as also you can see the sulfur dioxide, methane. Okay, okay. So now suppose I want to work for that methane. Okay, or if you want, you can also work for any gases. Suppose I want to work for the carbon monoxide. So this is the carbon monoxide. Just I simply click on here because I want to work with this data set. Okay, so basically in this time you can see we can get the data sets Sentinel-5 carbon monoxide data set, and it will be available between this time period of 2018 to 2023 0701. Okay, this time it will be available, and then we can get the data set provided is that European Union ES Copernicus. Basically all of those Sentinel data provide from the European Union and Copernicus. Okay, you can get all of the information from here about the satellite, and they're also it's also called the Tropomy instrument. Okay, and is a space borne. Okay, and it mainly this satellite observe about that different types of air quality parameters such as nitrogen dioxide, sulfur dioxide, methane, carbon monoxide, or other gases. It will be observed about that. Okay, and this is the Sentinel-5 Tropomy. We can get the data set. We can get all of the information about the data set from here, and it mainly spectral band with the expectation UV band. Okay, and this band is the 7 into 28 kilometer square. Okay, and short emitter band will be 7 into 7 square kilometer. Okay, so let's go about the data set. Okay, so now first of all you can also see the other description about the data set. You can see the description. So mainly this data set provide the offline high resolution imagery of carbon monoxide concentration. Okay, and also we can get the some information about the carbon monoxide. Okay, so it's a very important atmospheric trace gas for understanding the tropospheric chemistry. Okay, in certain urban areas it's major atmospheric pollutant. Okay, main source of carbon monoxide are the some of the fossil fuels, biomass burning, atmospheric oxidation, and methane and other hydrocarbons. Okay, so you also read about all of those terms. It also you can easily get from here about the information. We can also get some band about that. You can see the band is that first you can see the band carbon monoxide column number density. Okay, so basically it vertically integrated carbon monoxide column density. Okay, and it unit is the mole per meter square. Okay, its unit is the mole per meter square, and this is the mean and max value of this about that. And you can see the resolution of the data set. Okay, resolution is the 1113.2 meters. Okay, when you want to observe the carbon monoxide, we need to use this band. Okay, this is our band we need to use for observing the carbon monoxide. Okay, if you want to observe the water vapor, okay, then you can use this band. Okay, so it also also has the another information about the water vapor. Also you can see cloud height. Okay, scattering layer height. Okay, so in this time I want to work with this band and identify for the carbon monoxide density. Okay, so let's go. So first of all I simply copy that. This is the unique ID of this data set. So I simply copy and paste in my in here. Okay, and give a variable name. Suppose I put the variable name is that, you can use any name. So put the variable name is that CO. Okay, I carbon monoxide. I simply put the CO. You can use any name. There is no problem. After that, you can see mainly this image collection has a lot of band. You can see this image collection has lot of band such as carbon column number density. I want to work only for this band. Okay, so just I simply copy this band and then simply use a function in here, select function. Okay, from all of those band I select only for this band carbon monoxide column number density. This band I select. Okay, So after that, I can simply use a function, filter date function, for filtering a specific time period. Suppose I want to observe this carbon monoxide for year of 2023, then also put here the 2023, suppose January, suppose 31. Okay, so I put this, what is the condition about the carbon monoxide month of January year of 2023. So just I simply filter this time period. Okay, so now I check how many images are available between this time period. Okay, so just use a function, print function, and call this variable name and use the function size. Mainly it determines how many images are available between this time period. We can get about that result. You can see we can get the result about the 426 images. Okay, 426 images for 1 month, 2023 month of January. Okay, for the band of column number carbon monoxide column number density. Okay, 426 images we can got. Okay, so now I want to observe what is the condition about that carbon monoxide for the whole world month of January 2023. So what can I do? I just simply reduce this image collection. Why I reduce? Because this 426 image is not captured at the same time of the month of January 2023. It captured the different time of the month of January. So that's why I need to reduce and make it one composite. Okay, so reduce is an statistical function. So in this time, calculating from 426 images, I calculated the average result of the carbon monoxide. So for that, I want to simply show the result. So what can I do? Just I simply use the map dot add layer function, and then call the average CO and paste here and click to run. In this time, one layer will be added. Okay, so basically it represented the result of carbon monoxide density for year of 2023 month of January for the whole world. Okay, so in this time it looked like that because I did not add any visualization. So now let's check about the visualization. So here you can see, okay, they already provide some visualization code in here. Just I simply copy, because I need the colorful map so that I can easily identify where is the high density, what is the low density. Okay, and then paste in here. After that, simply copy this variable name and paste after the object name. So this is my object and paste at this and click run. So now I can get the very colorful map and I can easily identify where is that high density about that nitrogen dioxide and where is the low density about the nitrogen dioxide for the whole world. So now I can see the result about that. And this result is only showing for that year of 2023 month of January. Okay, so basically when you want to show the result, so mainly we can find out the high density for this region. You can see for red color is the high density about this. So it is the region of this type of region. You can get this result. Also you can get this high density for this region. Okay, so we can also get the some high density for this region also in here, United States. Also you can get this, you can see the South Korea. Okay, about this high density about that carbon monoxide. Okay, for this high density we can easily observe. Okay, it loaded, you can see. Okay, okay, so it's showing that carbon monoxide, what is the condition. Okay, you can see the result for the whole world. Okay, but in this time I don't need for the whole world. I need this result only for this suppose any specific country. Okay, suppose I need this result for Italy. So what can I do? I can simply import the Italy country boundary shape file. So here I already imported the Italy country boundary shape file in my asset. So just I simply put in here, import this boundary. And after that, what can I do? In this time, it's showing for the whole world, but I need to click with only for my shape file. Okay, suppose I put the shape file name is that RY. You can use any name, there is no problem. I put this name, suppose RY. So ROI. Okay. And then put here is ROI. Then click the run. So now I can get this result only for the Italy country boundary. What is the emission? We can get the result for Italy boundary. And you can see, basically in this time you can see there is a no color about the red color. Okay, red color is identified for the high emission of carbon monoxide. Okay, so for this country there is no mass emission of the carbon monoxide. Okay, I think about this country look like that. Okay, so you can see this is the concentration map of nitrogen dioxide, carbon monoxide for this Italy. Okay, and this result represented the month of January year of 2023. So basically in this time we can get this some high density. So here you can see basically red, it's the getter, high density, then yellow, then green, then cyan. Okay, so I think it is this level of the cyan color we can get in here. So this type of region for this Italy, it's showing the high density about that carbon monoxide emission about this region. Okay, okay, so this is our map, concentration map. If you want to check the value, suppose click on here, suppose for this region what is that value I want to check, and now click on this map. So now it's showing the result about that. You can see we can get the density for this specific coordinate. You can see I just simply open. You can see for this region we can get that for this specific coordinate we can get the 0.23 mole per meter square. Okay, emission of carbon monoxide. Okay, suppose I want to check the another place. So basically it's cyan color, it identify the high color, high density. Okay, as well as you can check the other, you can see 0.24. Suppose I have to check about that type of this type of color and check what is the result about this. You can see it's showing the 0.314. Okay, mole per meter squared density for this place. Okay, so this is the map about that carbon monoxide. Okay, carbon monoxide density map we can create it. Okay, and now suppose in this time I also observe the month of January. Okay, here the month of January when we can got the high emission of carbon monoxide. Okay, so for that we also need to talk about that time series chart. Okay, suppose in this time I also observe about that temporal changes between the month of January when the carbon monoxide is high, when the carbon monoxide is the low. So this type of analysis I want to observe. So that's why I need to create the time series chart about that. Okay, so let's go. We create the time series chart and also observe when it will be high, when it will be low. So this type of analysis. So let's go. And this type of map we can easily export. Okay, this type of we can easily export and make this type of map using the ArcMap software. After exporting, we can simply create this type of map using the ArcMap software. Okay. Okay. So in this time, if you have any question or any doubt, you can ask me. Any question or any doubt, you can ask me. Okay. Thank you. Okay. So let's go. Okay. So now it's showing that about our result, we can get the concentration map of Italy, month of January 2023. But in this time, we also want to observe what is the temporal changes about the different time period about this density. Okay, so let's go. So just I simply create the time series chart. Okay, so for the time series chart, we are using this function UI dot chart dot image dot trace. Okay, this is our function. So in this time here we can get the first argument is that image collection. So mainly image collection is that how many images are you want use in here. So how many images you want to use, you can see under the console tab how many images we want to use for creating this map, how many images I want to use. Okay, so basically this is my image collection. If I want to check it, suppose I just simply just print this result, how many images I want to use. So basically this is my image collection, how many images. So I simply use the size function and click the run. So now it represented that how many images I want to use for creating this map of nitrogen dioxide carbon monoxide concentration map for the Italy. I want to use 426 images, and this is my image collection. Okay, 426 images is stored in a variable. This variable name is the CO. Okay, just I simply copy. So this is my image collection value. Okay, so image collection is that 426. So now I just simply paste in here about this value. Then region is our shapefile variable name. Shapefile variable name is the ROI. Okay, reducer, I want to use at the, I want to observe the average density of carbon monoxide. So use at that TE dot reducer dot mean average density. Then scale is that 1113.2 meter. X property, I simply put here the X property is that system time start. Okay, so now I simply print that. So just use at the print function and use the parenthesis and also close this parenthesis. So close. So now click the run. So now we can check about the result, what type of result we can get from here. So now it's creating, and this chart is depend on your image collection. Okay, when you want to work for the big region, then it takes some time. Okay, and sometimes the chart is also not work. Okay, suppose when you want to work with for the big region, it's showing the some error. It's showing that 5,000 element is not approved for this creation of chart. Okay, then you also put the another method for creating this type of chart. So I will try to show you that. So now it's working. Okay, calculating the chart.